Hello and welcome to notes number 4 on adding and subtracting numbers with scientific notation. So we've seen that we can multiply and divide numbers while they're still in scientific notation. We don't have to put them back into standard form. So let's see how we can do that same thing with adding and subtracting. So here there's question number 1. A popular social networking site has the most members between the ages of 15 and 28. Within this age group, there are 5.11 times 10 to the 7th student members and 9.55 times 10 to the 7th non-student members. What is the total number of members in this age group? Okay, so I see that this problem has to do with students and non-student members, and I'm looking for the total number. So I see that it's a very large number of student members and another large number of non-student members, and I want to know what the total number of members is. So if I want to know the total number of members, I know I'm going to have to add these two numbers together. Well, I'm not really sure how to do that, so I'm going to turn them back into standard form because that I do know how to add together. So in the first one, I have 5.11 times 10 to the 7th. So if I put that back into standard form, I'm going to have 1, 2, 3, 4, 5, 6, 7. And if I do the next number, 9.55, this number will be 1, 2, 3, 4, 5, 6, 7. So in order for me to add them together, I have to line up the same place values and add them together. I see this is 95,500,000. This is 51,100,000. So I can just line up the decimal places so I have the same place values, and then simply add them together. So here are all zeros. 5 plus 1 is 6. 5 plus 1 is 6. 9 plus 5 is 14. Carry a 1. So I see now that this number is 146,600,000. So as long as I add the same place values together, I can add it. Now let's see if I could have done that with the numbers still in scientific notation, because I don't like writing all those zeros. It gets sloppy. So I see that both of these has the same power of 10. Here we have 10 to the 7th and 10 to the 7th, which means they both have the same place value. So since they do have the same place value, I can add them together. This is going to be 5.11 times 10 to the 7th and 9.55 times 10 to the 7th. And when I add them together, I can add together the coefficients. So that's all I have to worry about adding together. When I do that, I get 6. 6.5 plus 9 is 14. 14.66, and it's the same place value. So I do not change the exponent on the 10. So it's just going to be 14.66 times 10 to the 7th. And I see that that's what would be here. If I put the decimal after the 14 on the number we had before, I see it moves 1, 2, 3, 4, 5, 6, 7 place values, which would give me the 14.66 times 10 to the 7th. Of course, this is not written correctly in scientific notation. The decimal should be after the 1, so if I rewrite this to make sure that it's in scientific notation, this would be 1.466 times 10 to the 1st, because I just had to adjust it one place value, times 10 to the 7th, which would give me 1.466 times 10 to the 8th power. Let's see if that matches the number we got in standard form. If I wrote our original number that we got before into scientific notation, the decimal would go after the 1, and let's count the place values. 1, 2, 3, 4, 5, 6, 7, 8. It would be exactly that. So it's 1.466 times 10 to the 8th. So I find it much easier to add these very large numbers without having to write all those zeros in them. Okay, so let's summarize what we've done with this problem. So anytime you want to add or subtract numbers in scientific notation, the powers of 10 must be the same. So in that last problem we just did, both numbers had the same power of 10. They were both 10 to the 7th. So when you are ready to add or subtract numbers in scientific notation, what you have to do is simply add or subtract the coefficients, depending on whether you're adding the numbers or subtracting them. And then you keep the same power of 10. Whatever that power is, you have to keep it the same. Then once you've done that, just like when you were multiplying or dividing, you need to take a look at your answer. Make sure that your final answer is still written correctly in scientific notation. If it's not, you might have to rewrite your number. So, if necessary, rewrite your number in scientific notation. Okay, so we're going to add the coefficients, keep the same power of 10, and then if necessary, rewrite the number. Let's try example number 2. I have 2.45 times 10 to the 7th plus 3.8 times 10 to the 7th. So the first thing I want to check is to see if the exponents are the same. And they are the same in this case. I've got 10 to the 7th and 10 to the 7th. So since they're both the same, I know that I can add them together. I'm going to keep the same power of 10, but I'm going to add the coefficients. So I'm going to have 2.45 plus 3.8. When I add them together, I have to line up the decimals, line up the place values. I add them. 12 carry a 1 and 6. Okay, so let's try some of these problems to see how it works. In question number 2, we're adding 2.45 times 10 to the 7th plus 3.8 times 10 to the 7th. Both of these numbers have the same power of 10. It's 10 to the 7th and 10 to the 7th. So since they have the same power of 10, we can simply add the coefficients. So I'm going to be adding 2.45 plus 3.8, and it's important to line up the place values. So I add these together. 4 plus 8 is 12, and I'm going to get 6.25, and then I keep the same power of 10, nothing changes, times 10 to the 7th. And that's going to be my answer. So I don't have to put it back into standard form. I can just leave the answer just like that. Okay? And the same thing happens when I subtract two numbers. You simply subtract the two numbers, and that's the final answer you get. So let's take a look at number 4. I have 1.4 minus 5.67. The powers of 10 are the same. 10 to the negative 5, 10 to the negative 5, and I'm simply subtracting the numbers. Now, when I look at this, I realize that I'm actually subtracting a bigger coefficient from a smaller coefficient. So since I'm subtracting a bigger number from a smaller one, I'm going to end up with a negative answer. So all I have to do is line them up to subtract. So when I do line them up to subtract, I am going to line up the bigger coefficient minus the smaller, so that I can line up the appropriate place values to do that. So when I subtract, I have to subtract the correct place values. 5 minus 1 is 4. But I know when I'm done that my answer is going to be negative. So I'm going to have negative 4.27 times 10 to the negative 5. 10 to the negative 5 is the same as before. Nothing has changed. The only reason my coefficient happens to be negative is because I had a smaller number minus a bigger number. So that would be my final answer. I simply subtract the coefficients and keep the same exponent. Okay, so I'd like you to press pause now and try questions 3 and 5. Okay, now that you've tried these problems, I added in number 3, and I got 11.4594 times 10 to the 8th. But because 11, the coefficient is too big, it's bigger than 10, so I had to readjust my number, rewrite it into scientific notation. So there's my final answer, 1.14594 times 10 to the 9th. Now in number 5, again, you're subtracting two numbers. They have the same exponent of 10, which is good, except we're subtracting a bigger number from a smaller number. So once we subtract it, we know the answer is going to be negative. So it's negative 4.4 times 10 to the 7th. The exponent's not negative. It's the coefficient that's negative, because we're trying to take a bigger number away from a smaller one. Now let's take a look at the next page of our notes. In every example that we've seen so far, the powers of 10 have been exactly the same. However, what if we end up having different powers of 10? Then what do we do? Well, if you have different powers of 10, what you're going to have to do is you're going to have to rewrite one of the numbers so that the exponents are the same. And you're going to rewrite them using the same technique that we've been using up until now to rewrite numbers into scientific notation. Now you're going to have to choose one of them and rewrite them so they have exactly the same power of 10, because that's very important. You cannot add two numbers in scientific notation unless they have exactly the same power of 10. So then what you do in step 2, you add or subtract the coefficients, just like we did before. And just like we did before, you're going to keep the same exponent of 10. Third, once you've done that, you want to take a look at your answer and see if your answer is correctly written in scientific notation. If the coefficient is the right size, then you're done. Otherwise, you might have to rewrite the result to scientific notation. Let's try doing question number 6 and adding these two numbers. So I have 2.45 times 10 to the 7th plus 3.8 times 10 to the 8th. So this question is different because our exponents here are different. Here we have 10 to the 7th, and here we have 10 to the 8th. So they're different exponents. Right now we cannot add the numbers like this. I need to rewrite one of these numbers so that they both have the same power of 10. It's much, much easier if you rewrite the smaller one, because then at the end you won't have to readjust your number again. And I'll show you what I mean by that. So let's choose this first number, the one that's 10 to the 7th, and I'm going to rewrite this number so it's 10 to the 8th. I want this to have a 10 to the 8th in it. Now, I can't just change the number. I need to keep it the same value. So what I'm going to do is I'm going to multiply by 10 to some power so it's still equal to 10 to the 7th. So 10 to the 8th times 10 to what power is going to equal 10 to the 7th? Well, we talked about this in class. We did an exercise like this. 8 plus what is going to equal 7? Well, it's going to be negative 1. So 10 to the 8th times 10 to the negative 1 power is going to equal 10 to the 7th. Because if I add together 8 plus negative 1, it's going to equal 7. So I haven't changed anything. I've just rewritten it so it looks differently. And then I'm just going to copy over my coefficient, 2.45. So now it's a little bit longer. It's still equal to the same thing. If I put this number into the calculator or the original number, it's still equal to the same number. I'm just rewriting it so it looks differently. So now what I'm going to do is that this first part, the coefficient times 10 to the negative 1, I'm going to rewrite this in standard form. This 10 to the negative 1 tells me to move the decimal one place to the left. It's going to make it smaller. So now I'm going to have 0.245 times 10 to the 8th. And that's how you rewrite a number so that they have the same exponent of 10. I wanted both to have 10 to the 8th, so I rewrote the first number. So it's 10 to the 8th times 10 to the negative 1. And then I used that 10 to the negative 1 to fix my coefficient. So now I've got 0.245 times 10 to the 8th. This is just like we rewrite numbers at the end of the process, except we're going to do it at the beginning so that they both have the same power of 10. Now that they have the same power of 10, I can add these two numbers together. So I have 3.8 plus, now I have to line up the decimal places, 0.245. I'm going to add the coefficients, because when we add numbers in scientific notation, we add the coefficients. I'm going to fill in the zeros so I can add these together. And I'm going to add the values, 10 carry a 1, 4, and the decimal place I just carry down. So my final answer will be 4.045 times 10 to the 8th power. Because I simply add the coefficients and keep the same exponent of 10, just like we did on the front page. I add the coefficients together, same exponent of 10. Okay? This does have an extra step, but really it's just like readjusting your number at the beginning instead of rewriting your number into scientific notation at the end. Okay, so let's take a look at number 7. Again, in number 7, we're adding two numbers together, but the first number is 10 to the 5th, and the second number has a 10 to the 8th. They have different powers of 10. So we're going to readjust the smaller one to make it look like the bigger one. We're going to readjust this 10 to the 5th, so it's going to say 10 to the 8th. It makes it easier so that at the end it will be written correctly in scientific notation. So again, I'm going to write a 10 to the 8th because that's what I want it to be. But then I'm going to multiply by a power of 10 to make it equal to 10 to the 5th. So I'm going to think, okay, 10 to the 8th times 10 to what power is going to give me 10 to the 5th? In other words, 8 plus what is going to give me 5? 8 plus, well, it's got to be negative 3. 8 plus negative 3 is going to equal 5. So it's going to be 10 to the 3rd, and then I just rewrite my coefficient, 2.456. Okay? So now what I'm going to do is I'm going to use that 10 to the negative 3 to readjust my coefficient. So this 10 to the negative 3 tells me I'm going to have a small number less than 1, so I'm going to move it to the left 3 decimal places. So 2, I'm going to copy over my coefficient, and I'm going to move the decimal place to the left 1, 2, 3 decimal places. So I'm going to have 0.002456 times 10 to the 8th. So I readjusted my coefficient so that both numbers can have a 10 to the 8th. So right now this is not written correctly in scientific notation, but that's okay because I need this coefficient to add it to the other one. So now that the powers of 10 are the same, I can add the coefficients. So here I'm going to have 6.0034 plus point, and I got to line up the decimal places, 0, 0, 2, 4, 5, 6. So now I add the coefficients together. I'm going to fill in my zeros for the places, the place values, and I add them together. And I know this is an unusual number. Here I carry down my decimal place, and it's a 6. So that's my new coefficient. So when I add them together, my answer will be 6.005856 times 10 to the 8th power. And that's my final answer. So the difference between what we did before and what we're doing now is that we have to rewrite one of the numbers so that they both have the same power of 10. Then you add the coefficients and keep the same power of 10. Okay, now that we've tried 6 and 7, I'd like you to try 8 and 9 on your own. However, before you do that, I'd like to point out that there's a typo in question number 9, and I'm sorry about that. In question number 9, the first number has an exponent of 3 on the 10, and that's wrong. This number should have an exponent of 9, so it should say 4.801 times 10 to the 9th power minus 2.2 times 10 to the 7th. So if you could correct that typo, please. So it's 10 to the 9th power in the first number and 10 to the 7th in the second number. So if you could press pause, try the next two problems, and then press play again to see what the answer should be. Okay, so let's take a look at the answers here. In number 8, I had to readjust my numbers so that they were both 10 to the negative 5 power. So I rewrote my second number so that it would be 10 to the negative 5. So then my coefficient became 0.567. And then I had to subtract the two numbers, because in this problem the question is asking us to subtract them. So when I subtracted the two numbers here on the left, I subtracted them. I had to borrow here, and I subtracted the two numbers, and I got 0.833 times 10 to the negative 5 power. However, you'll notice here that the coefficient is too small. So therefore I had to readjust my number so it was written correctly into scientific notation. And so that's how I got the final answer of 8.33 times 10 to the negative 6. In number 9, I also had to readjust the second number so that it's a power of 9, 10 to the 9th power, times 10 to the negative 2 power. So I had to move the decimal to the left 2 places on my coefficient. Again, I subtracted. Here on the far right, this time I subtracted these two numbers, and I got 4.779 times 10 to the 9th power. Okay, I know these two problems are challenging because you had to readjust one of them, but with some practice, I think we'll get much better on it. So what I'd like you to do now is, on your own, I want you to complete questions 10 and 11. Both of them have to do with adding and subtracting numbers in scientific notation. However, this time the powers of 10 are all the same, so you don't have to worry about readjusting the numbers. All you have to do is add or subtract the coefficients and keep the same powers of 10. So I want you to complete questions 10 and 11, both parts of them, and bring those questions to class completed, and we'll go over the answers then. Thank you.